Okay, so this is page 26, lesson B-11, writing the equations of tangent and normal lines to a graph. Okay, so, all right, so we know what a tangent line is. A normal line is perpendicular to the tangent line at the point of tangency. Okay, so you've got, let's just do like a graph like this. Okay, just like a parabola, and we'll do like a little point there. So let's say that's the point of tangency. So the tangent line would look something like that. Okay, and the normal line would, let me use a different color. The normal line would go through the point of tangency, and it would be perpendicular to the tangent line. All right, so this here, that would be, I shouldn't use an arrow, but that's the normal line. Okay. Alrighty, so we're gonna need to have a formula. All right, so the equation of tangent line formula goes like this. It goes y minus y1 equals m tan x minus x1. All right, so we're going to need to memorize this formula, and this is going to be the formula that gives us the equation, not the slope, but the equation of a tangent line. And the equation of a normal line would go the same way, except you'd have the slope of the normal line here instead of the slope of the tangent line. Okay, so find the equations of the tangent and normal lines at the given point. Okay, so it goes like this. So we're gonna have x1, y1, and m tan. Guys, as soon as you have numbers for these three things, then you could use this formula. Okay. Now here is a case where they're giving us x1 and y1. That's the point of tangency. So x1 is 2, y1 is 1. And for m tan, guys, we're gonna have to do f prime of whatever that x is. So that's going to be f prime of 2 is going to be the slope of our tangent line. Okay, so they're giving us not function notation, but we have y equals. So y prime is going to be the same as f prime. All right, so that's y. So y prime is equal to 2x. Okay, so y prime is equal to 2x. So, no, so maybe I'll just switch notation. So f prime of x is 2x, just switching notation there. And then we have f prime of 2 is 2 times 2, which is 4. Okay, so m tan is 4. Okay, now as soon as you have these three ingredients, then you just plug them into the formula. So y minus y1 is 1 equals m tan is 4, x minus x1, which is 2. All right, and you could just leave it like that. All right, so this is the tangent line. Alrighty, now for the normal line, it's going to be very similar. Yeah, sorry for the mess. For the normal line, it will be similar. Let me go like that. For the normal line, we're going to have the same x1, y1, except instead of m tan, it'll be m norm. So 2, 1. The slope of the normal line, remember the normal line is perpendicular to the tangent line, and perpendicular lines have negative reciprocal slopes. Right? So the slope of the normal line, instead of being 4 over 1, it's negative 1 over 4. All right, so we have all of those ingredients. So y minus 1 equals m norm, which is negative 1/4, x minus 2. Okay. And guys, I just want to briefly, okay, so to graph this, let's just graph the tangent line and the original in a calculator just so we could see if it in fact looks tangent. So if you're going to graph this, to graph, solve for y. So you have y equals 4, x minus 2 plus 1. So let's just graph the original just to see what it looks like. Let's graph the original and the tangent line. So x squared minus 3. And then our tangent line, 4 x minus 2 plus 1. Now, if you want like a standard window, you go zoom 6. All right, that'll make sure that you've got like, you know, negative 10 to 10, negative 10 to 10. That's a standard window. And yeah, this looks perfectly tangent. Beautiful. Since we're in this window, let's graph the normal line as well and see what that looks like. All right, so I go here, so I'm gonna have to add the 1 over. So this is negative 1/4 x minus 2 plus 1. And then you hit graph. Okay, now guys, that doesn't look perpendicular, but that's because our window here, it's not like a square window. So what you could do if you're checking to make sure that looks perpendicular, you would go zoom, and then zoom square is the 5th one. So zoom 5, let's see if that looks more perpendicular. Okay, there it is. There's the normal line. Okay, and yes, that looks like it's forming a 90-degree angle with the tangent. All right. Okay, 2 more examples. Find the equations of the tangent and normal lines to the curve at the given x value. All right. Actually, guys, let's just do the tangent. So equation of the tangent, so I'm crossing off and normal. So of the tangent line. All right, here we go. So the ingredients that we need, we are going to need x1, y1, and m tan. All right, so in this case, x1 is 1. Guys, we are not given y1. So y1 is going to be f of 1. And then m tan is going to be f prime of 1. Okay, so for f of 1, I don't have to do anything to this. I just plug 1 in. So f of 1 is 1 plus 2 squared. That's 3 squared. That's 9. Okay, so y1 is 9. Now f prime of 1, I'm going to have to take the derivative of this. Okay, so right now we've got y equals 1 plus 2x squared. Now, when you're taking the derivative, you ask, is this a one-step derivative? This is not. We need to have just a sum of terms of the form ax to the n. So this, if it's not a one-step, we've got to do algebra. So what is an algebra move that we could do here? An algebra move we could do is expand. Okay? So I'm getting that y is equal to 1 plus 2x plus 2x, so plus 4x plus 4x squared. Okay, so that is still y. Okay, now I'm going to take the derivative. All right, I'll go like right there. So the derivative y prime is, the derivative of 1 is 0. The derivative of 4x is 4. The derivative of 4x squared is 8x. Okay, so that's y prime. So f prime of 1, that's just y prime with 1 plugged in there. So this is going to be 4 plus 8, that is 12. Okay, so now for my actual equation, I've got these three ingredients. So it is, let me box these up. You don't have to do that, but I just like to show that because these are the three things we're plugging in. So y minus 9 is 12 times x minus 1. All right, so this is the equation of the tangent line, not the slope of the tangent line, but the equation of it. And let me just, let's just check that. All right, so parentheses, 1 plus 2x squared. And then I have to add the 9 to the other side if I'm going to graph it. Plus 9. All right, let's see what it looks like. Okay, that looks good. You could all play around with the window too. Let me go zoom 6 and see if it looks a little bit better. Like a little bit more tangent. All right, that looks fine. But if you're not sure, like you could, like I'll put the y max to like 30 or something, just to make sure it doesn't intersect or like, yeah. Okay, that looks even better. Very nice. Okay, one more, guys, I'm sorry. Okay, find the points on the curve. A curve is a graph. Curve, graph is another name for it. So find the points on the curve where the tangent is horizontal. Okay, so you got to think about this. Tangent is horizontal, means m tan is 0. Okay, because a horizontal line has a slope of 0. So m tan equals 0. Guys, what's another name for m tan? Because we're trying to come up with an equation. M tan is y prime. So y prime equals 0. So this is a case where you're going to take the derivative, set it equal to 0, and then we will find the points. So we're going to have an xy pair. All right, so y prime equals, is this a one-step derivative? Yes, each of these terms is a one-step derivative. So 6x squared plus 6x minus 12. All right, this is y prime. We're going to set it equal to 0. You could take out a 6. Okay, and then this factors x plus 2x minus 1. So we're getting x equals negative 2 and x equals 1. So those are just the x coordinates, guys. So one of our points is going to be negative 2, f of negative 2. And then the other point is going to be 1, f of 1. So to get the y coordinate, you're plugging into the original right here. All right. So this one is negative 2. And then if you plug negative 2 in here, all right, let me just do it fast. We're getting 2 times negative 8 plus 3 times 4 plus 24 plus 1. Shoot. I did it. All right, so 2 times negative 8 plus 12 plus 24 plus 1. I hope I got it right. I got 21. All right, so that's one of them. And then the other one, I'm just plugging 1 in. So I'm getting 2 plus 3 is 5 minus 12 plus 1 is negative 6. All right, guys, so those are the answers. Okay, these are the two points on the graph where the tangent line is horizontal.